Welcome back to the deep dive. Today, we're targeting a very specific engineering problem, the headache of distributing ultra-high bandwidth 4K video over long distances in professional settings.
That's a huge one.
So we're doing a deep dive on a little piece of hardware that claims to solve it. The Blustream PRO-OUT2TCS board. The mission here is to figure out how this card moves 18 gigabits per second across a cable that should, frankly, choke on it.
Exactly. And to be clear, what we're looking at is a specialized modular card. It's an output card for their custom Pro Matrix hub.
Okay.
And its whole reason for being is to handle full HDMI 2.0 signals. So we're talking 4K at 60 hertz, 4.4.4 color, HDCP 2.2, the works.
Right. Let's unpack that immediately, because 18 TBPs over a standard CI cable, it sets off alarm bells for anyone who's designed an AV system. Standard HDBaseT Pro isn't built for that. So how are they pulling this off?
Well, this is where we get into the real technical meat of it. It does use HDBaseT for the distribution, but the breakthrough is what they call Advanced Color Space Conversion, or CSC.
CSC.
Got it. Since that 18 gig signal is just too big for the HDBaseT link, the CSC engine, it digitally manages it. It uses I'd say a very sophisticated, visually lossless kind of compression to squeeze it onto the wire.
Visually lossless.
Yeah.
That's the crucial phrase there, isn't it? The whole idea is to get that full color fidelity, that 4.4.4 chroma, but without the latency that compression usually introduces.
Precisely.
So practically speaking, how far does that signal actually go?
It lets you reliably extend 4K UHD video up to 70 meters.
70. Wow.
And if you're just running standard 1080p, you can stretch that all the way out to 100 meters. That's some serious reach on standard cable.
That is robust.
Yeah.
But here's where it gets really interesting for me, and I think for any system integrator. The nightmare of the mixed display environment.
Oh, absolutely.
You have a brand new 4K screen in the conference room, but an older 1080p display in the lobby, both pulling from the same source.
And this is the killer feature. I mean, it really is. It's the independent downscaling. The board takes that high bandwidth 4K input,
It's a full 4.4.4 signal.
the full signal, and it tailors the output for each screen separately. So if one display only supports 1080p, the card just handles it. It does the conversion right there on the board.
And it's even more granular than that, right? It's not just 4K versus 1080p. What about color depth? Say you have a 4K screen that just can't handle the full 4.4.4 palette.
Yes, absolutely. The card is smart enough to see that limitation, and it can deliver a 4K at 60 hertz 4.2.0 signal instead.
Which is so important, because if you send 4.4.4 to a screen that can't take it, you just get
a black screen. You get nothing. So this prioritizes compatibility. It makes sure you get an image while still maximizing the resolution that display can handle. The end user doesn't have to touch a thing.
That flexibility really is the key. And of course, it ticks all the other boxes professionals expect. It supports all the HDMI audio formats, Dolby True HD, Atmos.
Right, and it uses POSI power over cable, which is a huge deal. It can power the compatible Blustream receivers like the HEX100CS RX.
So fewer power bricks to worry about at the display end.
It just cleans up the installation. And physically, it's simple. Quick release fittings, you just slot it into the Matrix hub. It's built for installers.
So if we step back for a second, what's the real significance of having all this intelligence, all this resolution management packed onto one output card?
Well, what the Blustream PRO-OUT2TCS does is it shifts the entire burden. The whole problem of display compatibility and scaling, it moves it away from the endpoints, which are, notoriously bad at negotiating signals.
Right.
And it puts that intelligence squarely on the central matrix itself. It just removes so many variables, which, it raises a really important question for system designers today.
Okay.
As all these display technologies continue to fragment, how much should your centralized hardware, like this matrix board, be expected to compensate for the weakest link in your system? Should it always be built to guarantee perfect compatibility no matter what you plug in? It's a design choice that really defines how stable your whole system will be.